Today we are proving the formula for the sine and cosine of the sum of two angles. Looking up on the top right, we see that we have a right triangle with hypotenuse r and legs r sine of z and r cosine of z by definition of a triangle of trigonometric function. We will continuously look upon this as our reference triangle. Given this arbitrary right triangle with central angle A, we will construct a new central angle B by rotating the original triangle around the central point of the circle. This will create a new triangle in gold with the new angle A plus B. By this picture and our reference triangle, we can tell that the vertical length of our new triangle is sine of A plus B, and our horizontal length is cosine of A plus B. Our goal is to build the formulas for these.
To remove some of the clutter, we will hide the gold triangle for now and rotate our original triangle back to the horizontal radius. We begin with a unit circle. We constructed a right triangle with a central angle A. Our hypotenuse of the triangle we denoted as 1. And from our reference triangle, we know that the vertical leg is 1 times sine A, and the horizontal leg is 1 times cosine A.
Use the slider to rotate the triangle. We are constructing central angle B again. We then constructed another right pink triangle with a perpendicular line from this point to a horizontal radius with central angle B like so. Based off our reference triangle, our hypotenuse of the new triangle is in fact the leg of our previous triangle, 1 cosine A. This makes our new vertical leg cosine A sine B, and our new horizontal leg cosine A cosine B.
We then construct a perpendicular line segment from this point to this horizontal radius. We then constructed a line segment from this point perpendicular to the other line segment and also parallel to the horizontal radius. We will now label all of the angles that we know. Since we constructed a perpendicular line segment, this must be a 90-degree angle, forcing this other unknown angle to be denoted as C.
From our newly added line segments, we constructed this green triangle that by vertical angles, this angle is C as well. By definition of alternate interior angles, this angle must be B. Since the sum of the angles of a triangle is 180 degrees, and we have a right angle and some angle B, we know B and C are complementary. By the same reasoning, this angle is C, and the other angle is a right angle, then the last angle is B. Based on our original orange triangle, our new triangle in black has a hypotenuse sine A. After rotating our reference triangle to match our black triangle, we see that our vertical leg is sine A times cosine B, and our horizontal leg is sine A times sine B.
Since we know all of the lengths of the segments that we need, we will now hide the shaded triangles in order to remove clutter. Now, let's recall our goal triangle. For this specific triangle, we are interested in finding the sine of A plus B. And according to the reference triangle, we are looking for the length of the vertical leg. We know the bolded part, sine A cosine B, and we know this section is a rectangle. Therefore, we know the vertical sides of the rectangle are congruent. Thus, we know the yellow segment is cosine A sine B. Thus, sine plus the sine of A plus B equals sine A cosine B plus cosine A sine B.
We will now rearrange some of the labels in order to clarify our formulas. According to the reference triangle, if we wanted to find cosine of A plus B, we are looking for the length of the horizontal leg of our goal triangle. We know the horizontal leg of the pink triangle is cosine of A times cosine of B, and the horizontal leg of the green triangle is sine of A times sine of B. Considering the rectangle we referenced previously, we see that the horizontal segments are congruent. Thus, the bottom horizontal segment of the rectangle is also sine of A times sine of B. From this, we can conclude that the cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B.
The difference formulas, sine A minus B or cosine A minus B, can be derived by looking at the even and odd functions.